ஹஸ்பண்ட் நான் சொல்றதுக்கு. குட் ஈவினிங் சார். குட் ஈவினிங் சார். ஹலோ. 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 குட் ஈவினிங் சார்.
Yeah, Srinivasan, hello. Hello.
Yes, sir. I just wanted to check if connection is good, sir. Yes.
Yeah.
Sir, you are muted, sir.
Oh, sorry. I have to connect my iPad. I'm trying to connect the iPad. Just
Okay, sir. Yes.
Srinivasan, can you send me the
Yes,
link?
sir.
Yeah, can you send me the link in
By email, sir.
by email, because I don't know why this is not working. Just every
Yes,
time
sir.
something
I'll send it now,
happens.
sir. Yes, sir.
Okay, so before,
I have sent it, sir.
yeah, well, I haven't got it yet. So before I get it and go back to the iPad, I think ano- there are enough people.
So, Dr. Sundar, Dr. Karthik Kailash, sir, and Professor Pratibha and Dr. Srinath are there, sir. Other than you.
Yeah. Where are these two guys? Yeah, are you able to hear me? Oh, I think there is a,
Yes, sir. We are able to hear you, sir.
but there's an echo for me. 1 minute. Is it okay now?
Yes, sir. Perfectly fine.
Yeah. So we'll start. I think we have enough crowd. So we have been looking at number of things. Especially we were looking at functions, and we had seen that everywhere, anywhere, and everywhere, it is the function which plays a great role. Okay, let me now share a screen and just go to a function, okay, which we will see, because one of the questions yesterday was that how did you choose this function? So we will we will just answer that question in a minute. So you're a- you're able to see my screen, right?
Yes, sir. We are able to see it.
Yeah. So now let us look at, see, what is that we should do as you people, especially as doctors. What is that you should do? You should have an understanding of functions. Especially, essentially, you will use the 6 steps of functions. Okay, let me run it and show you how these functions would look like, and also their slope. uh, okay, now what are these functions? The functions are the following. You can see 6 graphs. Okay, now the first one you can see here, first one is called linear absorptions. It is in your profession, everything is absorption, change, and growth, or a decrease in certain things, and so on. So absorption is a very important phenomena for you. So what is absorption? Linear absorption. So that's the first thing. Just A into C. This is the equation. A into C. You can see it here. So linear absorption, because linear means it will just go straight line. So this is the curve. Linear absorption. Just straight, keeps on going. Okay. So that's the first thing. Then you have saturated absorption. A into C divided by K plus C. Now, what is this? Suddenly you introduce some K, suddenly you introduce A. So what does it do? Parameter A, whether it is A1 or A2, which I'm going to just put it for the sake of numbers, parameter A, as you can see, is a measure of efficiency, which means that with small values, there is low absorption. Large values, high absorption. If you now take, for example, uh, this graph, you would see that, look at this. And what is this equation? A into C. So if A is large absorption, which means that the blue will start shifting towards the left. So the curve will be something like this. Slope, as we would call it, will be high. Just wait for it for a minute. If it is low A, means it will be like this. Slope will be low. We had seen what is slope in the last class, so that's why I'm using that here. Now, then, so the A is a measure of efficiency, and small values producing low one. So there are two other parameters we are going to use, K and beta. K and beta describe the shape of the function. So what is meant by shape of the function? So the next equation which you will be using, quite often is A into C divided by K plus C. Okay. This is called saturated absorption. So in other words, you can see that this is the saturated absorption. So with time, it reaches a particular value. Okay. So what is that value? The value is A. So that is the saturated absorption. We had seen this before. Okay. So this is the second one. Then we have saturated threshold absorption. This is A C squared divided by K plus C squared. Now, don't worry about remembering each of these terms. Just look at that. So AC by K plus C, it will hit a plateau. That's what it means. So the third one is what is called as the saturated threshold absorption, which is AC squared divided by K plus C squared. This graph performs similar to that of the green saturated absorption, but the slopes are going to be different. We know what is a slope already. The slopes are going to be different. Now, apart from this, we have, see, what are they? You look at these functions like this. Blue, it's just increasing function. Green and red, it increases and reaches a plateau value. Then there are two other functions, okay, which is called overcompensation 1 and 2. So these two functions increases and decrease. So where do I use this? For example, drug absorption in the body would be an equation of the form AC divided by K plus C squared, or AC into E power minus beta into C. So these are the two equations that are used to look at the absorption of, say, some drug inside the body. Okay. And all, say, for example, enzyme kinetics, whatever you are looking at, they will be something like saturated absorption. Yesterday we saw that. Then you have enhanced absorption, which means that the curve will keep increasing more, more after some time, much steeper than linear absorption. So these are essentially the curves which become very important for you. Okay, so then we have to look at, we can look at the slope of these curves. We know what is a slope. Is there any questions on what is a slope? I hope everyone understands what a slope is. Any questions? No questions? Okay, right. So if there are no questions, you can see that there is, see each one of them, you can really understand it, and you can you yourself can draw it, but I have drawn it here. Now let us look at these two. Let's look at these curves from the point of view of a maximum. There are peculiarities in this curve. So what are the, can someone tell me what are the peculiarities as far as the maximum is concerned in these curves? Is there anyone who can help me out? Maximum is concerned. What about the linear curve? Yeah, please.
Does the maximum is the same C value?
No,
Okay.
no, it is not the C value. That is exactly what we are going to see. So now let us look at blue. Let us look at the blue value. So what is the equation for that blue? A into C. Right? It's here. A into C.
Yes.
Right? So what is the maximum value? Infinity. Because as you keep on increasing C, the value absorption will keep on increasing. Okay? So it's just a straight line. So its maximum is at the infinity. Clear? Okay. Now, the second one. A into C divided by K plus C. So that is this green guy. Right? So there is actually, in this case, do you have a maximum value?
Is it A?
Is it A? Anyone else?
To be A into C only. It can't be A.
A into C.
That value has to be the maximum.
Should
Keeping C
look
as
at that?
one
Look at that
or
equation.
whatever the value.
Look at the curve again. Look at the curve again. Okay, and maybe I'll put down the equation is A into C divided by K plus C. Right? Will be A into C. How do I now understand this graph? We have done this some time back. See, look at that equation. A into C by K plus C. Very famous equation. Many enzyme kinetics, all the reaction is by this equation. So how do I interpret it? As C increases, C keeps on increasing. Okay, then C plus K will be approximately equal to C itself. Right? So as C keeps on increasing, the value that this will absorb, or the absorption will realize, is just A. That is called saturated absorption. So you can see it here. So it just keeps on increasing, and then it reaches this value. Right? So this is called saturation. Saturated. So what do you mean by saturated? It means that if you look at this equation, what's the equation? A into C divided by K plus C. So this means that it will not be able to go to A correctly, but it will just be flattening at A. It will be very, very, very close to A. It could be not 1% of A, but it will be not exactly A. So it is sort of saturates at A. How far, how quickly it goes to A, that depends upon K. The K will decide how fast it's going to go. Then you have a nuanced one. That is, in other words, a better of this. Sometimes we have to use it. That is this equation. That is this equation. You will have a saturation. You can see that. It's called saturated threshold absorption. Similar to this, but the slope is slightly different. But these two curves are different from the first three. Why?
Because it has a decreasing slope, I mean, negative slope also.
No, yeah, it has, but yes, that what does it mean? We saw that last class, or previous, I mean, one or two classes before. What's that? We saw this before. So there is a maximum, right?
Equilibrium it's reaching.
So there is a maximum here in these two places, right? So there is a maximum. So what is meant by when there is a maximum? What does it mean? We saw that in the last class. In fact, red also has a maximum, but I mean, because it will just reach because of that function, small decrease also will be there with respect to, when there's an increase, but that will be subtle. It'll always be around A. But here, clearly it reaches a maximum and then drops back. So we saw this in the last class. What is reaching a function reaching a maximum? Jason was observing something.
It reaches a peak value.
Yeah, it's a peak value. So what happens?
Optimization of the.
No.
That's the maximum threshold it can absorb, and thereafter it has to have potential to fall.
It has to come. So with respect to slope, what is that?
It changes the sign.
So the slope will be
Negative.
Zero.
Zero at that point. Yeah, at that point, zero.
It will be zero. Right? So if I have to find the maximum, I can plot the slope and find out where it crosses zero, and that will give me the maximum point. Clear? So whenever there's a slope is zero, it gives a maximum point. But
just before it hits zero, it's maximum.
No. At the point where the slope is equal to zero, I'll explain that with figure in a minute. Okay, just watch that. So these two have clear maximum. So what is minimum? That we will see in a minute. On the other hand, if you go to black, again, it approaches infinity. Okay, so there is no maximum for this. Is that clear? There's no maximum for it. Any questions? So continuously, monotonically increasing will not have a maximum, obviously. There are curves. We will come back to this. There are curves or functions which will have a maximum value. These two have a maximum value. Okay. So how do I find out maximum value? Whether it will have a maximum or not, I need not plot it. I have to only do what is called as differentiation, find the slope, and the slope happens to be zero, then it will have maximum value. So if you look at the first one, let me not bother too much about other things. So if you look at the first one, blue, when I plot the slope, it's just a straight line. Okay, it is just a straight line. So it will never cross zero. So, which means that there is no, there is no, uh, it doesn't cross zero, which means there is no maximum, right? So the other one, this black, the slope just keeps on increasing. So again, there is no maximum. Clear? Any questions?
Sir, if the black one passes through zero, would that mean that would have a maximum?
Yeah, anything which passes through zero, this is the black one.
Yeah.
The slope has to pass through. If the
Yeah.
slope does not pass through zero, okay, then
Okay.
there is no question of a maximum.
Okay.
Clear?
Yes, sir.
Okay. Now, what is this? We will come back to this. I'll get out of the of this and go to my iPad and explain this, more pictorially. Close this. I'm going to stop sharing. I'll come back to my. Yeah, this is what we were looking at. Let's look at this. Let's look at these figures again. Now there is one more question. Imagine, before I put the graph, imagine that there is a curve which is increasing, decreasing. We saw that. There can be a curve which is decreasing and increasing. Clear? There can be a curve which is decreasing and increasing. Now, in that case, there is a minimum to that curve. Right? Say, for example, there can be a curve like this. Right? So this is the minimum. So what will happen to the slope when there is a minimum?
Again, zero. I mean,
Again, zero. So whether the curve is like this or whether the curve is like this, both cases, when it reaches a maximum value, there is going to be like this. And when it reaches a minimum value, the slope is going to be like this. Right? Is that clear? Second point. This is very, very important application. When the reverses is very important, slope reverses. Now, so can someone tell me, this is some function, say y, and this is x. Can someone tell me, how do I now distinguish between them? So now let's look at the slope. Let's look at this black one. So what's happening to the slope? It was steep like this. Then it was less. Then it went like this. Then again, it's like this, and so on. So what is happening to the slope? Slope decreases and then increases. Clear?
yes, sir.
So is that clear?
Yes, sir.
Right. So now if I plot the slope, how will it be? So this is positive, this is negative, this is positive. So I'm plotting for that black guy, this black curve. So which means that it will decrease Will the slope be like this? Okay, this is 0. So at this point, it is 0. So the
0.
maximum is at this point. Clear?
Yes, sir.
Clear? Now,
Yes.
I want to, let us look at that red guy. Okay? The red guy is like this. It's going like that. So how will red guy be? It will be in the
Opposite, like from above to below.
opposite direction.
Yeah.
Like this. Clear? It will be like this. So there is a definitely this difference is clearly observed. Here the guy is happily going up. This fellow is going down. Why? Look at that slope. So, but I still don't know. Both the cases it is 0. I can't keep plotting this. I want to just see it and see whether it is possible to see whether it's maximum or a minimum. Now, from these two curves, can you tell me how to find out whether it is a maximum or a minimum? How do I find out whether it's a maximum or a minimum? Anyone? Look at that curve very closely, that black guy. I'll give you a clue. It is not necessary that I have to look at the slope of the curve only. I look at the slope of the curve, this curve, and I plotted this. I can also look at the slope of the slope.
Then the slope of the slope would be positive
For
black line
exactly. And
negative for the red line.
negative for the red line. That's all over. Right? That's all. So if y is equal to function x, I write like that. That function is what we saw, so many functions. Okay, saturated absorption and so on. So if y is equal to function x, then what is slope? It is called derivative or dy by dx. Okay, I'll also put one mark there, that mark there, one mark. So this should be equal to 0. Okay, at the maximum position. And then slope of slope is called second derivative. So this should be
Greater than 0.
no way. It's coming down.
No, for y, okay, yeah, for red.
Yeah. Clear?
Less than 0. Yeah.
It's coming down. Now, if I plot that slope, it will just be negative. It will be like that.
Yeah.
And then the second one, the black one, is increasing. So what will be the slope of slope?
Greater than 0. Positive.
Positive. So I can find out like this. So what I need to do is slope, the slope of slope. That's all over. This is called maximum and minimum. So now if I give a function, you have to have the slope. The slope is easy physically to understand, but we call that as a derivative, differentiation. Derivative of the function. Differentiate is what is the term we will be using. So then second derivative or slope of slope. Now, interestingly, I can keep on taking slope of slope of slope. Then it is d cubed y by dx cubed. Slope of slope of slope of slope. Then d power 4y by dx power 4. How many times you say slope? That amount of time you put here. I mean, that number you put there. Yeah. Any questions? So now I know how to take this maximum, minimum also. Right? Any further things? Further questions? And shall we go ahead? Shall we go ahead?
Yes, sir.
Yes, sir.
Okay. Now, there are two ways of doing this. One is I can just go to MATLAB and find out what is the derivative of a function. We'll do that in a minute. But before I go there, some small things at least we should know. Let's just learn that without uh, bothering you much. We will learn a few of the things. Now, if you look at those functions, you can see that they come in a number of combinations of functions. We will come to that combination in a minute. So the first thing is, so this y versus say x, this is what we call it as a function. It can just be a constant function. So the y, whatever be the x value, is 5. So this is called as constant function. Then dy by dx, which is, look at the way it's written. It can also be written as y prime. We call that as y prime. Okay. Is equal to what?
0.
0. Obviously. So any constant, when you differentiate, you get 0. Okay. First thing, number one. So I can have a function like this. Y is equal to some x power 5. Then y prime, which is dy by dx, is 5 will get down from the throne. Then it will become 4. So in other words, in generally, x power n is what I write. Then its derivative y prime is equal to n x power n minus 1. These are some formula. You can remember at least a few of them. And if these are the things which are mostly useful, e power x. Then interestingly, we saw this in the last class, y prime is also e power x. Okay, the slope is also e power x. So you take second derivative, it is e power x. Right? So that is the first 3 things. We will look at later other things, but these are the 3 important formula which you can remember, or you can put it in ChatGPT and get it. No big deal. I'm not insisting that you should remember this. Right. That's the first. So I know how to take a derivative of at least 3 things. So let us say that I have a function which is, say, x squared plus 2x. This is a function. It can be a combination of these 3 fellows, what we just now saw. Then the question is, what is y prime? How do you view this? I would view it like this. So there is a function, y is equal to a function of x. That function can be also looked at as y is equal to one function plus another function. Please understand this carefully. One function plus another function. I can write it like that also. So in which case, what is the first function?
X square.
X squared. Brilliant. What is the second function?
2x.
2x. Jason, I think I have to bar you from answering.
Yes, sir.
You're answering all the questions correctly, that too.
Yeah.
Okay.
No, sir.
They're just joking. So there are two functions, right? Now, I want to find out y prime. Then it is very simple. It is the first function's derivative plus the second function's derivative. That's all. That is all. So which means that how do I write it? Someone else? Arjun? Sundar? Shanti? Karthik is there, right? Karthik. Yeah. So how do I write it? We already know it. X power n means it is n x power n minus 1. So what is x squared? X squared means what is the first term? This one. For this, what is? Look at that and then answer that question. What is n now?
2x.
2x. That's all. And for this, there is a small thing. There is one 2 sitting there. Let us for a minute, I'll remove that 2. I'll just tell that in a minute again. So I'll have only one x there. So if there is only one x, then what is f prime? What is n in this case?
1.
1.
So it's x.
How is it x? So 1 is coming down. So 1 into
So 1 bar. 1 into x.
into x power
N
what
minus 1.
0. 0.
0.
So x power 0 is what? 1.
0. 1.
X power 0 is 1. So this will become 1. So then I add it together. So 2x plus 1. That's all.
So 1 into x power 0 is anything into x to the power of 0 is 0, is it?
X power 0, anything power 0 is 1, not 0.
Okay.
So anything power 0 is equal to 1. X power 0 is equal to 1. Whatever it is, power something is 1. The power
Sure.
0 is, anything power 0 is 1. Clear?
Yes, sir.
So now I can have a function x squared, which we just now saw 2x. Then if I have 2x squared,
4x.
it is just 2
4x.
into the prime, which is 4x. So just multiply it. That's all. Okay. So these are the first addition simple rule. If it is minus, for example, it is minus, nothing. I have to only change here minus. That's all. Okay. Then this would become minus. That's all. So plus or minus, that's all it will become. The clear? Okay. Now there are other things that may happen. Let us see what are the other things. It may so happen that it can be a multiplication. So let us take one example. Okay, one example. But you may ask me, why am I interested in this? Why should all these functions? Where am I going to use it? So we have a, cancer specialist. So, say for example, there is a chemotherapy. See, chemotherapy has started. Okay, so there are two things that are happening. The volume of the tumor, as soon as you start, may still keep growing before it starts reducing. So, say for example, initial period is what we are looking at. So the volume uh, of the tumor may grow, say, at some rate or some as a some function, as some function. So which is say 100 plus 12t or something like that. I'll just explain that in a minute. I just lost this one. So and there is a density also. The cell's density may also vary. So now volume is varying with respect to time. Density is varying with respect to time. Now I want to find out how much mass is varying. You understood the question? So there is a volume which is varying with respect to time. And then I have density which is also varying with respect to time. But Dr. Bhagyam is interested in what is the rate of change of mass, because that's what gives ultimately the number of cells found and so on. So what is the rate of change of mass? This is the question she is asking. Is the question clear? Volume, we are giving a radiation therapy, volume is changing, density is changing. Now, what is the rate of change of mass? Now, what is rate of change of mass? Mass is yam. That is also a function of T. Okay. So what is mass? Density multiplied by volume. Right? Clear? Is that clear? Now, how do I write rate of change of mass? What is this? This is nothing but
d by dt of
dy. There's no y now.
d by
That's why I
dt.
changed. D
by dt of mass.
Yeah. So how do you write this?
dm by dt. Yeah.
So that is the rate of change. So that is nothing but the slope of the mass curve with respect to time. Clear? Slope of the curve mass. So if I now plot, so let's say that it's coming down like that, time versus mass, the slope of this curve, which may be like this or whatever it is. Okay, the slope of the curve is dm by dt. That is the slope. Clear? Now, look at this equation very carefully. The equation has two terms. Density is varying, volume is varying. Both of them are varying. I can't say that dm by dt is equal to dv by dt. I can't say that. When can I say that? Only if density is a constant. So by your therapy, both density is varying as well as the volume of the tumor is varying. So with the result that I have a function which is like this. So now I have to find out dm by dt. You understood the difference between the two? Density is not varying. It is simply a constant, some 0.8 over, no issues. Or 1.1, no issues. But density is also varying. So when I calculate this dm by dt, then what I do is, first I will keep density the same, then find out dv by dt, plus I will keep the density volume the same and vary. So this is how I calculate it. This is what is called as a product. This is a product of two numbers. This is called product rule. So what do I mean by this? So I have this 100. This problem we'll do, and we can easily find out from MATLAB. Will do it for us. Just a small practice. That's why we are doing this. Now let's see what is dm by dt. How can I write dm by dt as m prime? Both of them are the same. Is equal to rho of t 0.8 minus 0.05 into t. That is the rho of t. Here. So multiplied by dv by dt. What is dv by dt? Can someone say? 100 plus 12 into t.
12.
Yeah. What happened to the first term?
A constant, so it's 0.
0. So we are adding two terms. Okay. So our previous thing of this addition, we had that addition. So that comes into picture. We also know that for a constant derivative, it is equal to 0. So 100 is 0 plus 12t, right? So what is 12 into t? What will be the derivative of 12 into t? Something like this, x power 1, t power 1. What is t power 1? So what is for that? What is the derivative? For 12t, 12 will remain the same, right? The constant will remain. Then t, when I differentiate it, what happens to t? What is n in this case? This x power n, this guy. The x is of course t. So x power n. What is x power n? T power 1, right? Hello, guys, listening?
Yes, sir. Yeah.
Yes, sir.
So t power 1. Clear? So t power 1, what will happen? 12 into this fellow will come down into 1 into t power 1 minus 1. So what will that be?
12 into 1.
Into 1.
Yeah,
So that will be 12. That's all. So you will substitute in this place 12. So someone help me with the second one. Plus, now density is going to vary. So V will remain the same. 100 plus 12t. That will remain the same. This is V. So what is dou rho by dou t? Or sorry, d rho by dt. What is that?
Well, it's 0.8 minus 0.5 into 12.
Into t.
Yeah,
Right.
into 12.
That is the rho. Right?
Yes.
So rho, let me write it like that here for you. 0.8 minus 0.05 into t. Now, d rho by dt. What is the first term is 0.8. So what is the derivative of 0.8? Anything that's a constant, what did we say?
0.
0. 100 means it's 0. 0.8 means it's 0. 5 means it's 0. So all constants are 0. So the first term will be
0.
0. Second term? So minus not
Minus
5 will remain
0.
the same. What will happen to t?
T is 12. So
No,
it will
no.
be, no.
T is not 12. That's over. That is for dv by dt. Here, this is this one.
This will be
T power 1 minus 1.
T power into that is T0.
Yeah, T power 0.
Yeah, so it's again into 1.
So this is equal to minus naught. That's all. That is all. Okay. Now, that is what I'm going to substitute it here into minus 0.5. So let me write that whole thing for you again. So which means that dm by dt is equal to first term 0.8 minus 0.05 t multiplied by 12 plus second term 100 plus 12t multiplied by minus 0.05. So that is equal to when you just multiply. So this multiplied by this, so it becomes 9.6. Second term, if I multiply this multiplied by this, it will become 0.6 t minus 5, the first term, this and this, minus 0.6 t. So this would become 4.6 minus 1.2 t. So that is the rate of increase of the mass. Now, rate of increase of the mass or rate of decrease of the mass? That's the next question. Okay. Now, therefore, in order to understand that, whether, so in other words, will the mass increase or decrease or what will happen? This is the rate of increase of the mass. So that's the question. So will it, can someone guess it? This is the slope. Now, this is what I want you to develop intuitively. First thing. So dm by dt is equal to 4.6 minus 1. Is that clear for everybody? dm by dt is equal to 4.6 minus 1.2 t. Right? Tell me how this graph will look like.
This
Question number 1. Will it reach a maximum, or it will keep on increasing, or it will keep on decreasing? That's the first question, right?
Yeah.
Yeah.
If you take the second derivative and if it's negative, it will have a maximum.
Exactly. But before that, whether this will have a maximum or a minimum or keep on increasing, how do I find out?
This has a negative slope, so
yeah, good. So
minus
So anything
minus
minus
mx.
1.
This is in the form of minus mx plus c.
Hey, let's not go too much. You're very, very technical. Let's go step by step. A very nice answer, but let me not bamboozle others. I'm only looking at what I have learned. I mean, what I have taught so far. I'm going to come to that in a minute, but so what did we say? Whether it's a maximum or minimum should exist? What did we say?
4.6 minus 1.2 t is equal to 0, sir. Then maximum.
Exactly. If it is 0,
Yes.
then
It has a maximum or minimum.
a maximum or a minimum. I don't know yet. Maximum or a minimum. If it is 0, this is what we have been seeing here, right?
Yes, sir. Yes, sir.
This is what we saw here, right?
Yeah.
Maximum or minimum means that first derivative should be equal to 0.
Yes.
Right? So you solve this equation. So 12t is equal to, I'm going to taking it to the other, 1.2t is equal to 4.6. So t is equal to 4.6 divided by 1.2.
1.2.
So this would be the time for Okay. 3 into and 5 by 6. Okay. Point something. Right. So this is the time. But I don't know yet maximum or a minimum. How do I find out whether it's a maximum or a minimum?
Second derivative.
Second derivative, slope of slope. So now this is the function. Now what is the new function I have? 4.6 minus 1.2t. So this is the slope. I have to take the slope of slope. So I have to now differentiate one more time. Can someone help me in differentiating, which I would call as d squared m by dt squared? Can someone help me? What is the 4.6? What is the derivative?
0.
0.
That's 0.
Yeah.
Minus
Minus
1.2 into minus 1.2t, 1 minus 1.
yeah, 1 minus 1, 0. So t power 1 minus 1. So what is that?
Yeah. That's it. Minus
Minus
1.2. 1.2.
minus 1.2. So what did we
So
say?
negative slope.
Negative slope. Slope of slope is negative. So if it is negative, what did we say? Go
It's
back.
It
maximum.
is regressive.
So it is red curve or black curve?
The red curve.
Red curve.
Red curve. That's all. So the mass of this thing, of this tumor,
Is reducing.
is first increasing because it's a maximum it has, and then it is reducing. And the time taken is this, say nearly 4. Suppose this is 4. So it will start reducing. So it can be 4 sitting or 3 sitting or whatever. I mean, you can say that, or weeks. It can be on weeks. So it will start reducing afterwards. Is that clear? What is maximum?
Yes.
Any questions?
In this particular case, because that was a straight line, that would be easier to just follow the straight line equation, right?
Yeah, right. I have not yet written the straight line equation. So let us look at the straight line equation. So this is an equation, right? Or this is I would call this as a function because it's easier. You'll hear about more about this. So, so this equation what we have has 3 terms. One is 1.2, the other is t, the other is another constant. There are 3 things there. So on the left hand side, let us say that y is equal to, so some number into x. In this case, that number is t. See, please, I'm wantonly doing it. T, x, I will use it just interchangeably. You should not get confused. It can be t, it can be x, it can be a, it can be anything. Sometimes alpha, whatever it is. The form of the equation is important. That's all for you. Not whether t or x or whatever it is, because t can be time. Okay, x can be volume. Something, it can change. Doesn't matter. So m into x plus c. So this is the variable. X is a variable. Y depends on x. So x is called as independent variable. For example, this is the time. So here, this time is nothing but an independent variable. Y depends on x. Y has to follow x. So y is called as dependent variable. Okay. So is that clear? These are the 2 things. Independent variable. So when you plot a graph or you go and read a paper, independent variable will be in the x-axis, this axis. Dependent variable will be here. That's how you plot. Okay. Now let us look at this equation. Y is equal to mx plus c. Okay. Before I plot it, let me draw a line here so that you don't get confused with the previous one. Before I plot it, I want to find out the slope of this equation. So what is slope of this equation? Dy by dx. What is the slope? Differentiate it yourself. Now you know everything. So you have mx plus c. M is a constant. It can be 4, 5, 6, 7, 8, whatever it is. Constant into x. So what will be the slope of constant into x? Constant.
Constant.
Right? Here. See, I have mx. What will happen to this m? That is x power 1. M into 1 into x power 1 minus 1. So that is equal to m. So differentiation of this function is constant. Yeah. So what is dy by dx? Some can summarize now. What is dy by dx? What is dy by dx from this? What is the derivative of another constant c? That is, Jason has been telling this. What is that? We saw that.
0 is what you said.
Yes. Why? When it is a constant, it is equal to 0. So now summarize. So for this equation, give me dy by dx. What? Easy. Nothing.
Is equal to m, sir.
Yeah.
M.
That's all.
M.
That is all. Dy by dx is equal to m. So what is dy by dx? We called it as slope. So what is the so what do you conclude from this? What is m? M is a constant. Say for example, y can be 5x plus 4, right? It can be 5x plus 4. Clear?
Yeah.
So now dy by dx is what? From this you tell me. What is m?
5.
5. So
5.
dy by dx is equal to 5. So the slope
5.
is equal to 5. The slope is a constant. Right. Clear? Slope is a constant. So wherever I go, the slope has to be a constant, which means that if I now draw this curve, x versus y, there will be, this is the curve, so that the slope is a constant, because you remember that we had talked about slope to be just that, and that is going to be that angle tan theta we said in an earlier class. That's going to be a constant. So the slope of this curve is a constant, and that is equal to m. Wherever you go to x, slope is only one value, that is one constant value of m. It is independent of x. There is no x here. There's no x here, only m. So independent of m. The slope is constant. Now, let me write this again. Y is equal to 4x plus 3. That's the. So what is the slope? 4. Clear? Now, what is this 3? Where does it come into picture? This 3. Where does it come into picture?
Where it crosses the y.
Where it cuts. So how did you find out? Because
So
when I put x is equal to 0,
0.
which is this value, so y is equal to 3. So this value. That's all. Clear?
Yes, sir.
Yes. Yes.
Okay. So y is equal to mx plus c, the line equation gives me the slope, which is 4, and also tells me where it cuts the y-axis. That's all. Clear? We have learned a
Yes, sir.
lot of calculus. Now, let us say y is equal to 2x squared, okay, plus 3x plus 2. Let's say I have an equation of this form. So what is dy by dx? Can someone help me? 2 is a constant. For x squared,
2x into 2x.
Into
2
2x.
into x, because 2 minus 1 is 1, so it is x. Clear?
Yes.
Yeah.
Plus 3x.
3.
What happens to 3?
3.
Plus
3
0.
plus
0.
0.
0.
Because
0.
2 is
0.
0. That's all. So this is equal to 4x plus 3.
4x plus
4x
3.
plus 3.
So now, how will the slope of this curve look like? I mean, how the derivative? How will the curve of this slope look like, or derivation, first derivative look like?
Straight line.
Straight line.
Straight.
Okay.
Yeah.
So with the fact that there is x, how should this curve be? Suppose tomorrow you meet this curve. How will this curve be? The slope keeps increasing. As x keeps increasing, slope keeps increasing. So the slope will be like this, keeps on increasing. Straight line. So the curve, the slope keeps increasing means what? The curve has to be something like this. Initially, the slope is small. So as I keep moving in x, the slope becomes bigger and bigger. So that is what happens as I go on. So the slope is now not a constant, but is a multiplication of x. So this is how you view the graph, or the function, or the equation. Clear? A little bit I'm not doing
Yes, sir.
MATLAB now because I want some things to be, I would say, pushed in. Okay. Am I talking too much of theory? So let's check this. There are a lot of, all of you are doctors. So now all of us know purpose of hemoglobin, right? And we know that oxygen is bound to hemoglobin and so on. Okay. So what is a function which actually relates the binding with the amount of hemoglobin? So the function actually, the property of binding to hemoglobin, certain activities of enzyme, all these things are defined by what is called as Hill function. The Hill function appears like this, Hx. It's used in a number of applications in biology or physiology. So x power n by 1 plus x power n. Okay, this is the function. That looks quite complex. So now, what is that? How do I rewrite this function? This is like function of x by function 1, function 2 of x. So it becomes something like, okay, we have not seen what is called quotient. One divided by the other. There's a numerator and a denominator. So then, how does, say, for example, binding of oxygen with respect to hemoglobin, okay, is given by this function? So the question you may ask is, okay, if a hemoglobin content goes up, will the oxygen binding be better and better? And will, uh, you know, how does that vary? So how will you express that? The question you will ask is, how much is the oxygen binding will improve if hemoglobin content goes up? So in mathematically, how do you ask this question? How will you ask this question?
The slope of the function.
No. Yeah, slope of the function. Correct. So how is dH by dx? How is it that is behaving? Right? Remember, we said this long ago. I want you to look at all the the lectures. Please go back and refer to all the lectures. So it is dH by dx. This is the question you'll ask. How is this increasing? Is it increasing, decreasing? What's happening to x? All those kind of things. Right? So I'm not going to tell you how to do this because we will use MATLAB, because there is it's a slightly more complex when there's a quotient. Don't worry, we will do that with. So now, is that clear? This is an interesting equation, actually. Why is that you use this equation? Why do you use this equation? So if I ask Dr. Sundar, so what do you think should be this function? How do you think, as a doctor, how do you think this function should look like?
You mean the slope, the shape of the slope, sir, or
Shape of this curve, how do you think would look like? You know it very well, but I'm just.
it's like parabola.
No, it should be a saturation,
Well,
because that is what you look at SpO2.
Yeah.
Okay. So it should saturate. Something like this curve. Right? So
Yes.
the curve should be something like this. That's why there is suddenly the whole thing drops back. Clear?
Yeah.
So the slope is different at different places. Up to 95, you are fine. Then top. In fact, n is equal to 2 will be still worse. And so on. So the physiology is captured by that equation. That's all to it. Okay.
Yeah.
Is that clear? How to differentiate it, you don't worry about it. We will do that in MATLAB, because we can do it much later now, or else unnecessary confusion will be there. Now we will not do that. Any questions? Any questions? Okay. If there are no questions, we will go to the slightly. Is it clear? Take a minute. It's okay if you have any. Okay. Now,
Yeah.
The problem actually is unfortunate. I can tell you this. The equations which in actually physiology and your thing, what you face is much more difficult than us. In engineering, everything is happily linear. That's all. We are very simple people. You guys are very complex people. You know, drug concentration in the blood. If I'm now going to write an equation, you will get scared. So how does the drug concentration with respect to time, if it varies? Anyone has a clue? Of course, you would immediately say one thing. It is going to increase and decrease, correct? Yeah. Now, how would this function be? Any clue? What do you think should be of this function? Okay. A typical equation, the concentration with respect to time, is this one of the equations I lifted. 2.3 e power minus 0.2 t minus 1.65 e power minus 0.4 t grams per liter. This is the equation. Right? So now let's do one thing. We'll not do it now. We will go to ChatGPT. Please take your ChatGPT. I'm going out of this and I will go to my computer. Right? Okay. Let's get this. Okay. Now I'm going to share my screen here. Where is that? Yeah. Everybody see my screen? Yeah, maybe I'll do that again. You're able to see my screen?
Yes, sir. We are able to see the screen.
Yes. Yes, sir.
Yeah. Okay. We will do that in our chat GPT. That's another thing. What is my chat GPT? Yeah. Right. I'm going to write. So I'm going to say, write a program, write a MATLAB program. You can also try it. To differentiate is what that is derivative. Differentiate the function C is equal to 2.3. E is written as exponential. E power minus 0.2 t minus 1.65 exponential minus 0.4 t. Okay. Now write a MATLAB to differentiate. Plot the function and the function and the derivative. That's all. I don't want to do anything else. We will do this. Let's see how it works. I hope I have written it correctly. So it's still coming up. No way. It's slow. My network is slow. Right now it was coming up very fast. Is anyone getting it faster than me? Is anyone else trying?
Yes, sir. Mine is saying some server is overflooded with messages and something like that.
Yeah, that's what is happening. That's why it is so slow. I have a premium version. In spite of it, it is very slow. Okay, we'll wait for a second. Stopping there. I think the server is overloaded. Yeah, now it's started. Okay. So diff is the function. See, first what it does is sims t. That means that it's a symbolic manipulation. So it is going to that means that a function is given, it is going to differentiate like what we do. So the next line, that is sims t. The next line is the function. It has defined the function. I hope I have written it correctly. Minus 0.2, 2.3 into minus. Oh, I think I made a mistake. No, I've not made a mistake. I think that's the function. Just took it from somewhere. Point. Yes. So then that is the function CFT. Then it is going to, you have to differentiate it. Diff is the command. Diff. CT, that function, differentiate. You're telling by that term, say this differentiate. So you're telling that dc by dt, there's no by, you can't put it. So this is how you use it. Differentiate the function CT, okay, with respect to time t. That's what you're told. So that function diff is used. Okay.
So I got the whole code, but it didn't give the symbolic variable thing. It straight away start with the calling variable at the rate.
Yeah, that's okay. At the rate is another way of defining the function. It can, okay, it can write like that. But I know how you typed it. Symbolic variable is better. I know it takes so much of time. Okay, we'll do one thing. We will do it by hand, and you know, we will come back to this in a minute. So let it because I want to plot it and so on. So let me get out of this. So I'm going to get out of this, and I'm going to share my screen in the iPad. Yeah. So let us now differentiate this by technique what we know, right? So I want to find out dc by dt, right? So dc by dt. Help me out. So 2.3 will remain the same. Okay. Now I have a small difficulty. Why? Small difficulty. Because e power x I know. So,
T is there.
So when e power t is there, say for example, y is equal to e power t, then what is dy by dt?
E power t.
E power t, same thing. Clear? Any questions?
Yes.
So, but there is a difference between the two. What is that? I have not t, but I have minus. Okay, I think just give me a second. I'll just 1 second. I think it done. Just check that 1 second, because this I had to teach you some more fundas in that. Just give me a second. 1 second. I'll just get that MATLAB stuff easier to. Okay. Now I'm going to shift because there's no time. It'll take a few minutes. So I'm going to go back to my MATLAB code. Okay. Sorry to shift again. So I'm going to just go back to my MATLAB code. I'm going to share my screen. Are you able to see my screen?
Yes, sir.
Yeah.
We are able to see it.
So what I did was, now this guy has developed, I mean, this is what it was struggling. So here is a MATLAB code for what I had. You're able to see my screen, right?
Yes, sir.
Yeah. So you can see it. So this is what I gave. So it gave me the complete code. I have cut, I have pasted it in my MATLAB, and here is this code. Okay. I'm going to now run it. So I've asked it to plot the function as well as the derivative. So here is the function and the derivative, right? So you see that it is increasing and decreasing, right? Though actually the derivative is complex, I'm not very worried. I know what is the meaning for derivative. Okay, so though that it looked complex, if I now start deriving it, it becomes difficult for you to understand. But I'm not very worried about it, because I can use straight away MATLAB to differentiate it. So now this is the function. That's the function. Now, what is the derivative? So what do you expect from this, from whatever you have learned now? Whatever you have learned, what is that you will expect?
The slope is initially positive and then negative.
And then negative. But
So
first
basically
thing, before that,
saturated absorption.
no, before everything, before all that, the first immediate thing,
Maximum.
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 There is a maximum value, and where is that maximum? When it is equal to 0.
0.
So that is the point. First thing, slope goes to 0 here, and that is exactly the maximum value here. 1.8 something. Yeah. So that is exactly the maximum value. And first thing is slope goes to 0 here. Clear?
Yes, sir.
Okay. So the if I now, so this is first thing very clear. The slope is for, I mean, it's positive first, and then it goes to negative. Right. So now let's get this. So let's get this thing. So now the t value is up to 100. Maybe we can understand it better if it is 200. Let's see what happens if it is 200. Okay. So you can see that it is sort of becoming straight, and sorry, this is not the first one. Oh, sorry, 200, not, I made a mistake, sorry. 10, it was 10, I'll make it 20 rather. Yeah. Yes. Yes. So look at that. I just made this 20. Okay. That was an hour, so I made it 20. So you see this increasing, decreasing, and sort of straightening. Slope is now at this stage, as you go out, that is going to be almost a straight line. So that is exactly what's happening here. The slope is going to be 0 because it is hitting a straight line. So the slope tells a lot about that curve, and I didn't even differentiate. So I asked MATLAB to do it, and it has done this. So now this is, in fact, when I was doing a survey, this kind of equation is available for all the drugs. So when its appearances peak, then how does it come down, and so on. So all of them, many of them are these equations. So these numbers are the ones which are going to play a big role. So one of the things we can do is actually change them to find out how the drug absorption works. So that we will do it maybe in the next class. So we now saw quite a bit about derivatives. We will see a lot more in the next class. We will see a number of applications. You need not worry about all the equations. So we will have a complete idea as to how to interpret and where all it is used. We will see that a similar equation is used for, say, radiation therapy. Let's look at that equation in the next class. How does that look like? What is the slope? And what is meant by slope? Again and again, we will be seeing it, and we will understand it more and more. So you do this exercise, run the program, okay, and understand the slope. Keep looking at it and understand the slope, and then maybe last, a last question. Say. So this is, what is this curve? This curve, I said that the concentration of drug in the blood. So if this curve is given to you as a doctor, what would you look at? This is how you're prescribing a drug. This is important. Can you tell me a drug where you feel this curve will be totally different? This is in hours.
Drugs with longer half-life.
Yeah,
what can you, as doctor, can you give me an example?
No, any of the sustained releases.
Yeah, correct. So that is the difference. Sustained relief was immediate. For example, drugs that are prescribed for fungus, for fungus.
Sustained release will have same plasma volume, so it should not get peak and down.
No, but if you
can be a long half-life, in the sense like digoxin will be absorbed in the cells, and the half-life will be more in that sense.
Yeah, it is staying will be more, but its peak will also be later. So many drugs, for example, you have drugs that are used for fungus infection, right? You
Yeah.
use
Yeah,
one per
weekly once
week or
also.
something like that.
Weekly once
right?
we do.
Hello?
Weekly once we do this.
Weekly once.
Yeah.
Okay. Its curve will be totally different from this.
Yes.
Okay. So it would be interesting to see how this curve varies from one to another. When does it peak? Okay. Then it has to see. It's not that. So the next is, what is the next step that we'll see in the next class? So that's what I'm building up. The next step is what Dr. Sundar said, and that's exactly what I expected and said that. How is this absorbed into the tissue and so on, right? So that would be the next step. So we will see how cascading functions now become important. Two functions. This may be what is appearing in plasma.
Yes.
The next is how is this getting into your system? So that means there are two functions.
Yes.
Now, how do I deal with two functions here? Clear?
Yes, sir.
So that is what we will look at in the next class.
Yes.
Okay.
Yes, sir.
Thank you. Any questions?
The next class, the Sunday's class, or you mean Monday's
Sunday. Yeah. So Sunday we will have a class. It will be it will be at IIT,
Okay.
because I want you to bring your system, and we will have a tutorial session where I want you to become more and more familiar with MATLAB. I have 3 of my guys who will also be helping you, and so we will meet at 10 o'clock in our lab.
Okay.
It will be 2.5 hours session, maybe up to 1 maximum.
Okay.
10 to 1.
ED 20, first floor in Department of Engineering.
First floor in ED.
Okay.
I will also mention the room number in the group for convenience to come.
Yeah, I think just mention the room number. Okay. Yeah. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.